All right, hello again. This is Jeff Scott with the final presentation for 152, 143, Intro to Java Programming. When I say final, the final PowerPoint presentation, because during this first semester I'm only going to go through chapters 1 through 11 of our 17-chapter book. I'm doing the PowerPoints from the starting out with Java, from control structures through objects, 6th edition by Tony Gaddis. Again, these are the PowerPoint slides that accompany the textbook of the same name that we're using for the class in the spring 2016 semester. So chapter 11 is entitled Exceptions and Advanced File I/O. So we talk about exceptions, including exception handling, throwing exceptions, and then we get into talking about files. As I mentioned in an earlier lecture, an exception is something that is unexpected, and it's unexpected in a bad way. All right. And I also mentioned that when we talk about throws and exceptions being thrown, the Java throws exception, you as a user can throw, singular, an exception. If an exception can possibly happen, it's your responsibility as a developer to write code that detects and handles it. If you don't, the system keeps going up the call stack to see what function called that function, what function called that function, or method, etc. And eventually, if it doesn't find anything to handle it, it goes up to the top of the program and the program will crash. Alright, so Java allows you to create your own exception handlers. And an exception handler, as mentioned here, is a piece of code that responds. You know, I don't disagree with what the author says here about that it gracefully responds, but the point is, it's the programmer handles the response to the exception. This is known as exception handling. The default exception handler, so if you don't write one as it says there, it'll print some kind of an error and it'll crash the program. All right. An exception is an object, so there is a class exception. So with what we had been looking at in here earlier, so if I come in here and I go back to java.sun.com and I go down to the, as we've been doing, go down to the APIs, go to API 8, and once I come in here, I just look, for instance, well, I think we should be able to probably find exception in here, I would think. There's exception. So it is a Java class. Now, notice what it says here. Notice what it says. Direct known subclasses. These are all the built-in Java exceptions that can be raised. The ones that you're going to find most often are going to be IO exception, number formats exception, array out of bounds exception. All right, so let's see. And if you look here, for example, there's number format exception. Notice it's a child of class exception and class runtime exception, etc. as you work your way down. Thrown to indicate that an application has attempted to convert a string into a numeric type, but the string does not have the appropriate format. All right, there's a bunch of other ones. Again, I can go back up to the top and I can find the array index out of bounds exception, thrown to indicate that an array has accessed an illegal index, etc. And there are a lot of them that exist in the language. All of the exception classes as mentioned here are derived from what are known as the throwable class. And the children of throwable are error and exception. And we're going to look at these. I think there'll be a picture there in just a second. Okay? All right. The one thing about this that we'll talk about right now is there are errors and there are exceptions. And typically, you don't write a lot of code to handle errors, because errors are typically things that, as a developer, that are beyond your control. As it says, if there's some kind of an error in the Java virtual machine, or if you run out of memory, you shouldn't write code to handle that in your application. First of all, it really and truly should never happen. And secondly, if it does happen, it's not something that you as a software developer are probably even trained to handle. All right? So what we're saying is there's a bunch of stuff that comes down here under error. And they're not showing it here because this is stuff as a developer you don't handle. But this stuff that's in here, that is stuff that you do handle. So to handle an exception, what you use is what's called a try-catch mechanism. And actually that's not even complete because there's another optional component you can put on the end that's called finally. But in this try block here, where it's got try block statements, you put in code. There can be one line, there can be many lines that could conceivably fail. All right? If all the code goes through and it doesn't fail, you skip the catch and you jump down to the bottom. But if you try and something fails and you got an appropriate catch statement in here, then you handle that code and then you go down here. One thing you can't do, because people ask this question, is, okay, I did a try, I had an error, I made some changes here, can I do a go to and make it go back up there? No, you cannot do that. But there are ways that you can try to handle it inside of the catch statement. So as it says, the try indicates that a block of code will be attempted. And the curly braces here and here are required. This is the try block, this is the catch block. You have only one try block, and you can have multiple catch blocks for the same try. Then you can have more try blocks, etc. Whatever it is you need to put in. So notice, and I've already mentioned this, but just to be complete, a try block is one or more statements that are executed that can potentially throw an exception. Ideally, it won't, but what we're saying is if an exception is thrown, we want to be able to handle it. Because if we put a catch block, and you can have several catch blocks in there. You aren't limited to just one. But if you put a catch block in, and it is the correct catch block, then what's happening is you, as a developer, are handling the error situation. Okay? It's not that the default exception handler will handle it and crash the program. So as it says, the catch clause begins with a keyword catch, and in here you put the type of exception that you're trying to catch. And there'll be examples. All right, we'll see them maybe even in the next slide here. Here's an example. Okay? So we're putting code in here. We're attempting to create a new file that's called myfile.txt. All right? And we're attempting to basically use a scanner to open that file. But if for some reason we can't open the file, it's not found. So why would that happen? Maybe we don't have permissions to do this. Maybe the file system where we're trying to create it is full, or we don't have permissions for that file system. It can be different things. So it tries to do this. And let's assume for a second that this line here fails. All right, then the system jumps down and it says, okay, was the problem here a file not found exception? And if it was, just print out file not found and continue. Now you can do a lot of things. It's not just that you can put in a line of code that tells you you made an error in the exception. You can do a lot of other stuff in there. You'll see a little bit more, some more complex examples as we go on in here. So you try. Some kind of an error is thrown. And the system starts to look through one or more catch statements to try to find one that can deal with the exception. If it can, even if there's several, it finds the first one that it feels like can deal with it, and it executes all the code between those curlies. As it says, the parameter must be a type that's compatible with the thrown exceptions type, and after the exception, the program continues just past the catch block. So notice it says file not found exception E. What is E? You can call this anything you want. E is just the name. E is for exception, to be honest with you. All right. Each exception object has a method that's called getMessage. That if you want to use that, what it will show you is it will show you the text that the system threw, the default text, and it gives you the default error message for the exception. Again, we'll see examples of this as we go on. All right. Notice when handling exceptions, you can use a polymorphic reference. All right. And again, you can have multiple catch clauses. We're looking here. So what are we attempting to do here? We're attempting to take some string and convert it to an integer. So ideally, this will be a string, and it'll be a string that's got double quote followed by some whole number followed by a double quote. We're attempting to parse that into an integer and put it into number. Well, if we had an error, maybe what we had in there was the word hello, maybe it was blank. Maybe number wasn't of type integer. All right. Notice when we did this before, we put in file not found exception E, and then down here it says exception E. Well, exception is the most generic type of exception you can find. And what you'll see in just a couple minutes is if you have multiple exceptions like this and you decide that one of them should be an exception of type exception, that must be the last one. They must go from the most specific to the most general. So this will say the following error occurred, and then whatever the system writes down there, that's the e.get message. The E is from here, and the get message is again the built-in method that can be used to retrieve the default error message text. All right, as it says, the code in a try block may be capable of throwing several different exceptions. And so then a catch must be written for each one so that, that could potentially be thrown. The JVM runs the first compatible catch ones, and the rest are basically skipped. So if you notice in here, first of all, this is an error situation because you can't have the same exception. Number format, number format. That's why it's an error. All right. This is wrong because number format is a more, for lack of better words, it's a more specific error than illegal argument. So to fix this, you would have to take the code that you have right here, and this code that's right there would have to come up above this code that's right here. So in other words, we flipped the order in which those two were shown. And once we flipped them, then it was in the correct order, so it would then work. All right, that's exactly what the author is showing you right here. Just flip them around. Now, it is possible that after one or more catch statements, you can put finally in there. Now, the thing about finally is, if I try to do all the try stuff and it works, then I skip the catch, but I do whatever's in the finally. If I try to do the try and it fails, and I do whatever's in the catch, and that gets done, I do the finally. So the finally is typically, it runs whether the try succeeds and the catch is skipped, or whether the try fails and the catch executes. But what the finally does is it does housekeeping operations. So basically what it does is it closes any database or file connections that you have open. All right, so as it says, the statements in the finally block execute whether an exception occurs or not. All right, the stack trace. Well, what happens is when you have an exception that runs, the system will show you all of the method that was running when the program blew up, and then it'll show you the method that called that method, and then the method that called that method. So it'll show you, that's called the call stack. So it'll show you a list of all the methods that were executing around the time the exception occurred, and it'll show you the order in which they were shown from the most recent to the least recent. Now, as it says here, beginning in Java 7, you can specify more than one exception in a catch clause. So in essence, what this says is if either this exception occurs or this exception occurs, if you want to handle two different exceptions with the same code, you can put an or in there. Notice it's just a single pipe, not a double pipe. Notice as it says here, when an exception is thrown, it cannot be ignored. If you don't handle it, the default exception handler will handle it. When the code in a method throws an exception, the normal program execution stops. The Java virtual machine searches for a compatible exception handler inside the method. If it doesn't find one, then it looks to whatever method call that method for an exception handler. And it keeps going up the call stack until either it finds one that can handle it or it reaches main, and if it still can't find it, the program is halted, the default exception handler takes over. It handles the exception by closing down the program. right? There are two types of exceptions. There's unchecked and there's checked exceptions. Notice unchecked exceptions are those that are derived from the error class. They're thrown when a critical error occurs and you should not handle them in your code. Rather, you should handle checked exceptions. So all exceptions not derived from error or from runtime exception are checked exceptions. As it says, if the code in a method can throw a checked exception, the method must either handle it or it must have a throws clause listed in the method header, which at least tells the compiler that it is possible that an exception of this type can be thrown. If you don't put one of these in or the other, you're going to get an error message. So as it says, this program will not compile. And what's missing here? Notice we've got public void display file string name. This can possibly throw a file not found exception. So you didn't. If you need to put throws there, and since it's being thrown by Java, it's throws with an S on the end. Remember, you as a developer can throw singular an exception, but throws with an S on the end is something that Java does. So we're trying to display a file, but what if that file doesn't exist? So you put here throws file not found exception. That is sending a message to the compiler that says, hey, it's possible that there could be this kind of exception that gets thrown by this method. So as it says there, you can write code that throws one of the standard Java exceptions, or you can even write your own. So you can create your own exceptions. I'm going to show you this when we go through the code examples. And this is kind of a dumb one, but notice it's throw because it's a user exception. Throw new exception out of fuel. The author says don't confuse throw with throws. Again, you throw, Java throws. So again, you can create your own exception classes. They must extend the Java exception class or one of its derived classes. So we're going to look at an example, all right, in the chapter that says, here, if you had a bank account, what could be the possible problems? So what if you passed a negative balance into your constructor, or a negative interest rate, or a negative deposit value, or a negative withdrawal value? What if the amount passed to the withdrawal method exceeded your account balance? You can write your own exceptions to handle 1, 2, 3, 4, or all 5 of these conditions. Not only can you do this, but if you're writing java.comments, you can write an add exception tag in the java.comments to put more information in. Now that's pretty much it as far as exceptions go, but that's only the first part of the chapter, because the second part talks about files. All right? And they mention that the way that data is stored in memory is sometimes called a raw binary format. It says data can be stored in a file in its raw binary format. Well, what the heck does that mean? I don't know if you've ever tried to do this, but I'm going to come in here and go out to my desktop, and I'm going to grab, I've got a file here. Swift is open source, and you should care .docx. And I'm going to double click on it and open it up. You see it opens up in Word. Okay, it's got a few pages in it. All right, but it's got some stuff in it. Not a problem. But now I'm going to come in and I'm going to grab that same file. I'm going to right mouse click on it and say open it in Notepad. And you notice it looks like a lot of garbage because the file itself is in a binary format. It's in a special format that only certain software can understand. So I'm trying to open up a .docx, which is a Word file, in a non-Word editor. All right? When you use a product like Notepad++, it's expecting that you're trying to open up a file that's a text file, something like this. All right? So that's what it expects that you're trying to do. And you notice that once I open that up, I could double click on it and open it up, and it opened it up into an editor. Or I can right mouse click on it, choose edit Notepad, and again, it comes up okay. All right? So, as mentioned here, the way data is stored in memory is sometimes called raw binary format. Okay, a file that contains binary data is called a binary file. There are some types of data that should be stored in its raw binary format. Binary files cannot be opened up in a text editor like Notepad. If you're working with binary files, you must use objects from the file output stream and or the data output stream. Notice that the file output stream allows you to open a file for writing binary data. It provides only basic functionality for writing bytes to the file. The data output stream allows you to write data to any of the primitive types or string types. It can't directly access a file, but it's used with the file output stream in connection with a file. So they're going to show some examples here. So I've got this myinfo.dat. All right, so that's going to be a brand new file. Okay, and after I do all this stuff, then I'm more or less, for lack of better words, I'm wrapping it. I'm wrapping that file output stream around a data output stream. You may or may not be aware of this, but again, if I go back to this file I showed you before, all right, and this says here 152 urls.txt. I'm going to make a copy of this file because I don't want to screw it up. So I'm going to make a copy. So I copy it, and there I'm pasting. And there it is. It even says 152 URLs. All right, so I'm going to change the name of this, and I'm going to call this junk. All right, so if I open up junk, it opens up fine. Not a problem. It's the same file. But if I change the extension from .txt, for example, to .dat, as they showed in the program, first of all, when I do this and I hit enter, it comes back and it says, hey, you changed the extension, the file might become unusable. Are you sure you want to? I say yes. All right, you may or may not be able to tell, but the icon changed. It doesn't look like a piece of paper anymore. But now if I double click on it, what happens? The system comes up and it says, you've got a file there with an extension I don't understand. So how do we want me to try to open it? Now I can still come in here and right mouse click on it, and I can still open it up in Notepad. All right? Or I can still right mouse click on it, choose an open with, you know, I have to junk around with it a little bit, but open it up in regular Notepad. But I cannot. By default, it doesn't know what to use to open it up because I've changed its extension. Oftentimes you take these two statements that they showed right here and you put them into one to do that. And as it says, once the data output stream has been created, you can use it to write binary data to a file. And they go through an example, and we'll look at that a little bit later. All right, not in this lecture, but in a later lecture. To open a binary file up for input, as it says, you wrap a data input stream object around a file input stream object. All right, whether you do it in 2 lines or 1 line. The file input stream constructor, as it says, will throw a file not found exception if the file that you named cannot be found. All right. Once you've done it, you can use it to write your data to the file. To write to a binary file, says use the data output stream class's write UTF. And if you want to read from it, you use the read UTF. All right, UTF, I believe, it's either universal or uniform. I think it's uniform transformation format. And as always, because I do this all the time myself. So if I want to come in here, Google, what does UTF stand for? What is the code UTF? It's Unicode transformation format. All right? And you can see it means a lot of things. But this example here, all right, it's Unicode transformation format. So here's how you can write a string to a file, and there's how you can read a string from a file. The File output stream constructor takes a second optional parameter. If you don't put one in, if we do it like this, if there was something previously inside of myinfo.dat, it's removed. All right. Basically, you put the file pointer, what's called a file pointer, at the beginning of the file, and anything that was in there was removed. However, if you write it and you put true in there, it saves the information that was previously in there and it appends the new information to the end of it. All right. Sequential access versus random file access. Sequential access, I'm dating myself a little bit here, so some of you may not know what this stuff is, but back in the olden days, you had things like cassette tapes. So if I had a cassette tape and I wanted to listen to song number 7 and the cassette tape was at song number 1, I could do two things. I could either fast forward through the first 6 songs, or I could listen to the first 6 songs to get to song 7. All right? But I have to go from the beginning to the end and keep going. Now, sequential access works fine for a lot of applications. For example, for a payroll application that you run every week or every 2 weeks, they're typically done in a sequential way. It's easy to do, okay? But Java, like most other programming languages, also allows you to do random file access. That's more or less like using a CD where if I want song number 7, I can just press a button and boom, it goes right to song number 7. All right, so I can jump anywhere I want. When you're working with random access, one of the things you deal with in here is your mode. You want to open up a file for reading, which means read only, reading and writing, so of course you can do both. So there's a lot of different ways that you can set this up. Notice again, when you open up a file for reading and it doesn't exist, a file not found exception is thrown. If you open up a file for R mode, which is read only, and you try to write to it, you get an IO exception. So there's different exceptions that can be thrown for different reasons. The random access file class has the same methods as the data output stream for writing data and the same as the data input stream for reading data. All right? This file pointer is something that you may or may not have ever heard of. That, for example, if I create a brand new file, what happens is an invisible thing that's called a file pointer is opened up and it's set to the beginning of the file. Okay? And there's other things with it too. As it says, it holds the byte number of the location in the file. When a file is first opened, it's set to 0. When an item is read from the file, it is read from the byte that the file points to, and then the file pointer moves. An end of file exception can be thrown when you go past the end of file marker. The random access file class, as it says, lets you move the file pointer. You can use what's called the seek method to move wherever it is you want to go. One thing about using random files is every record in a random file has to be the same size. Because if every record is, for example, 100 bytes, then the system knows if it wants to go to record 20, it has to multiply 100 times 20, which will give you 2,000, which will pump you ahead 2,000 bytes, and boom, then you'll be at record 20. All right. I believe the last thing that's discussed in the chapter here is object serialization and deserialization. And the bottom line is, and you're going to hear me say this more than once over your tenure at Black Hawk Technical College, and that is, it's possible for you to try to go and shove 10 pounds worth into a 5-pound bag. And in this case, what I mean by that is you may create yourself some kind of an object. And you may decide you want to take that object and send it over the internet. Well, the internet can only handle a certain amount of information at a time. You may or may not have heard of this, but if you go and take a class with Denny Wright or Arinda Conway, they'll talk about the fact that when you send things over the net, that they get sent in what are called packets, and these packets can only hold so much information at a time. And if you've got more information than that would fit into one packet, you've got to break the information up into several packets. All right? In much the same way, as it says, if an object contains, becomes complicated, Java allows you to serialize the file. When you serialize it, you convert it into a series of bytes that contain the data. All right? And you can save it to a file, or you can do whatever you want to do with it. And when you go in the other direction and you want to put it back together again, it's deserializing it. And maybe this is a good example, maybe it's not, but this is one I've used for years. If you remember the show that was on a few years ago, Home Improvement, at the end of the series, Jill, who was the mom, she got her master's degree, I think in psychology, and she got a job as a psychologist in Indiana. Well, they lived in Michigan for the entire show, but they decided to move to Indiana. They were packing up their house, and they were talking about how much they were going to miss their house, and Jill said, boy, it's too bad we couldn't just take the house with us. Well, then Tim, who was always thinking of things, got like an 18-wheeler, took the house off its foundation, and they were going to port it over. Now, that's not typically the way it was going to happen. You would think about something like that happening, but just imagine for a second that their house was a brick house. And even though it was a brick house, they could take the house apart brick by brick, move it someplace, and then put it back together again. The act of taking it apart brick by brick would be serialization. The act of putting it back together again brick by brick would be deserialization. Okay? All right. And they talk a little bit in here about how that's done in Java land. All right? So we've come to the end of Chapter 11. So I want you to understand, I don't have to save this, I want you to understand what I'm going to end up doing, okay? So let me show you this. Oops, I don't want .com, I want there. I want .com. I have, in fact, I don't even want to use, well, I can't use this. I can't. Okay. On the H drive, I've got to go back into the virtual desktop. But on the H drive, if you weren't aware of this previously, in fact, not even on the H drive, I should say on the P drive for the class. Let me very quickly go over this with you. So if you go out to the P drive and you go out to CIS and you go out to 152, 143, Java 1, there's different things there. Okay? This is how I set my stuff up. For instance, archives are from really about the last time or so that I taught the class. So I just throw stuff out there that's old and put it in archives. All right, here's what we have now. Okay? So there's a bunch of stuff out here, and what I was looking for actually isn't here, but it's not a problem. But these are the appendices for the book that the author provides, some articles that I found on Java, the case studies that the author provides in the book, what we'll do in class, and that has to be moved, but that's okay. The PowerPoints, which I'm going over right now. Again, I've gone over the first 11 out of 17 chapters. All right. The source code from the book, the syllabus, and the course evaluation. But somewhere out here, and I thought it was there, unless it's one of the ones I just moved and put it in archives, but I don't think that was one of them. No. And I can't find it right now, but somewhere I found a PDF copy of the textbook. All right. And I want to show it to you. I thought I had it on CourseSmart.com, but I really and truly don't think I've even got it out here. I can check, but I don't think it's here. This is my tool as an instructor. I'm provided with online copies of some of the books that exist. Some authors choose not to do this, some do. So if I go down and find, here are the Gaddis books that I have access to. All right. Starting out with Visual Basic 2008, starting out with Python, C++, an older Java book, another older Java book, a Logic book, a VB 2010 book, another Visual Basic book, another C# book, another Java book, another Java book, etc. But I don't see the actual one from the class that we're going to use in the class. So what I will do is I will find my copy of that and put it out there so you're all able to get a hold of it. I'm going to next start going through all 11 chapters, and I'm going to build at least one program for every one of those chapters. And we'll start on that very shortly.